All right, so let's take a look at this problem. Again, we're working with parabolas. Um, we look at that and we see that only one variable is being squared. It's the y variable. When y is being squared, we know the parabola will either open to the left or to the right. So let's determine the vertex and then the sign, the value of p, and we can answer whether it opens to the left or to the right. I like to put my squared term and those variables on the left-hand side. You don't have to, but that's, I don't know, just habit. So I've got y squared minus 10y. I'll leave myself a little bit of room because I'm going to come back and complete the square. On the right-hand side, I have 4x minus 17. So I look at this, the linear term, this negative 10, and I take half of it. Half of negative 10 is negative 5. I square that negative 5, I get positive 25. By adding that amount, that makes this trinomial a perfect square. Half of the negative 10 we said was negative 5, so we have y minus 5 quantity squared is equal to 4x minus 17. And then since I've added 25 to the left-hand side to balance the equation, I'll add 25 to the right-hand side. So I have y minus 5 quantity squared is equal to 4x plus 8. I need to get the coefficient in front of x to be 1. So I'm going to factor a 4 out. It's convenient that 8 is divisible by 4 so that I don't have a fraction here. All right, so I can easily identify the coordinates of the vertex. It is negative 2, comma 5. Be careful and do not put 5, comma negative 2. The value of p can be determined by taking 4p and set it equal to the coefficient. So p has to be 1. And remember, since y was being squared, we knew that it opened to the right or to the left. Since p is positive, I know that this parabola opens to the right. So I've got this parabola opening to the right. It is symmetric with respect to this line that we call the axis of symmetry. We have another line that's perpendicular to that axis of symmetry that's called the directrix. The parabola will always open away from the directrix. And inside the bowl of this parabola is a point that we call the focus. All right, so we've already found the coordinates of this vertex, negative 2, comma 5. If I move to the right of that point, that's going to affect the x-coordinate. And if I move to the right, I'll be at the focus. If I move 1 unit to the right, negative 2 plus 1, it'll have coordinates negative 1, comma 5. Both of these points lie on this axis of symmetry. It's horizontal, so the equation is y equal, and both of these have a y-coordinate of 5 because they lie on that same horizontal line. Perpendicular to this y equals 5 is x equals, and on 1 unit, this time to the left of the vertex, negative 2 minus 1 is a negative 3. So there we have found all 5 things that they wanted. They wanted the coordinates of the vertex, the value of p, the coordinates of the focus, and the equations for both of my lines, the directrix and the axis of symmetry. So I hope that helps, and I'll talk to you later.